Hey everyone, welcome back to Hands-On Engineering. My name's Arun, and today this tutorial will concern Altium Designer, where we're going to create a very simple circuit that I'm going to show you right here. So you can see the circuit. It just has one battery, 100 picofarad capacitor, a single diode, and one 1 kilo ohm resistor, and of course ground. So let's just get right into it using Altium Designer to create this circuit. So this is the software. So this Altium Designer lets you lay out the circuit in a schematic and then lay out a PCB to represent that circuit as a physical component. So that's what we're going to do, both of those things today. So to start, we want to create a new project in Altium Designer by going to File, New, and then Project, and go to PCB Project and the default template. You can name it whatever you want, so I'll pick something simple, something like simple circuit, and you want to make sure that you've checked this box right here that is labeled Create Project Folder. This will create a directory for you to store all of your project files in automatically, and that'll be really useful because we'll be creating multiple files during the course of this tutorial. So we'll click Browse Location, and that'll bring up the where we want to store this directory. So I'll just store it in a folder in my documents, Altium, and we'll just store it right there. Great, and then we'll hit OK. So now you'll notice on the left side here you've got your projects tab where your simple circuit project, or whatever you've named it, is listed with the file extension PRJ PCB. The first thing we're going to do, you can navigate between your different tabs here, but we'll be on projects. The first thing you want to do is add a schematic to your project. So the way to do that is to right click your project name, go to Add New to Project, and go to Schematic. So this is schematic. This is your schematic sheet, and the first thing we're going to do is save that and name it something. So I'm going to name everything the same name as my project. That'll simplify things later on, as I'll see. So as I'll show you. So we'll name the schematic also Simple Circuit. We can zoom in on it and pan using the scroll wheel and the right click on the mouse, respectively. And let's add some parts to it. So we want to make this circuit. Let's add some parts. So let's add to add to parts. We go Place and then Part, and then in the Place Part window we go to Choose. And this is our libraries window, so we can browse between our libraries and see what components are in our libraries. Currently I don't have any libraries, so I'm going to add some. I go to these ellipses next to the drop-down menu and go to Add Library, and I'm going to select Miscellaneous Connectors and Miscellaneous Devices, which should come with Altium. It'll be in the library folder in your program files. So we'll just open up those two libraries and then close out of this window, and now we can access them. So the first thing we're going to do is instantiate a battery, just like that, and we'll give it a designator, BT1, and click OK. And now you see our cursor has a battery component attached to it. So we'll just place our battery somewhere convenient. We'll put it like right there, and I'll put it right here. So once we've placed it, you can see Altium automatically instantiates a second battery if we want it, but we don't, so we'll just hit Escape to close out of that cursor, and we're back in the Place Parts menu. So we'll just choose another component. This time we'll pick one of our capacitors, and again we'll relabel our designator, and we'll hit OK. And so we'll just place our capacitor somewhere reasonable and close out, and choose our next component, which is our diode, and label that one D1, and hit OK, and put our diode like right there. Close out and choose our final component, which will be our resistor. There's a resistor. So we'll pick the resistor, we'll hit R1, hit OK. And we'll put that right about there. And that's all of the parts that we need, so we'll close out of our place part menu. And now we need to add, if we refer back to our diagram, we've got all of our parts, but we need to add a ground. Very important we add the ground. So to add the ground, we'll go up to this toolbar up here, and you can see there's a ground power port option here. So we'll click that, and just like with the other parts, we can move it around. We can use the spacebar to rotate it. So I've been rotating parts using the spacebar, and just place it right there. And we only need one, so we'll get rid of the other one. So those are our parts placed, and they're approximately in the right positions. If I wanted to, I could change the values on this capacitor and on this resistor. So if I wanted to change this from 100 picofarads, I could just double click the label, and it would bring up the parameter properties, and I could change this to whatever I wanted to. But I'll leave them both the same. This should be fine. So now to place wires, we go to place and wire, and that will allow us to establish connections between our parts. So you know when you are establishing a solid connection between the wire and the part when your cursor X turns red. So you can see it's not red here, it's red here. It's not red here, it's red here. So we want to make sure that all of our wires are connecting to our components in the right place. We're not overshooting or anything like that. And another thing you'll notice is that whenever we draw a circuit schematic, you want to use straight lines for your wires, and you want to move at right angles. Whenever you turn, you want to turn at right angles. And this is a convention you use when designing a lot of circuits to make things easily readable and understandable. So yeah, that's all of your components connected. You can see some nodes where your wires are intersecting. Everything looks good. So let's hit save, and let's verify that we've connected everything properly. And the way we do that is go into project, and we can actually compile our schematic. And so when we hit compile, well, nothing's happened. And that indicates that there aren't any problems. So if there are problems, there'd be a little pop-up window and tell you what the problem was. You'd have to fix it. Maybe you forgot to connect a wire properly, or there's a component that's you've forgotten is off in space somewhere here. But yeah, this is pretty simple. No troubles. So the next thing we want to do is add a PCB. So this is our physical representation of this circuit using a printed circuit board. So to add that document, we right-click our project name, and we go Add New to Project, and we add a PCB. Select PCB, save this, and we want to name this the same thing we named our schematic file. This is kind of important, that we name this the same thing we named our schematic file, which is the same thing we named our project. So this will help with this next step, which is importing this circuit topology into our PCB. So the way we do that is we go to Design, and we go to Import Changes from simple_circuit.prjpcb, and these are our changes. So you can see we're adding 4 components to our PCB. We're adding some wires referred to as nets here, and we're adding a component class, because our component class is where basically the name of our schematic. So at this point, you want to uncheck rooms. Rooms are a way to organize your components from different component classes, and making sure that you're not mixing up circuits from different schematics. But since we only have one schematic and one PCB and one project, we don't really need to worry about this. So it's more trouble than it's worth, so we'll just get rid of it. So we'll validate changes, and everything's fine. All the changes that we want are good, and so we'll execute and close out of this window. And now you can see the components have appeared in the corner here. So we'll just select them all and drag them over here and just put them in this corner on our board. And one thing you can tell is that the board is way bigger than what we need for these components. So why don't we make it smaller? So to understand how to edit the board, it's important to discuss the 3 ways in which you can look at the board when you're dealing with PCB documents. So if you press 1 on your keyboard, you'll see that your board turns green, and this is your board design view. So this is where you can actually change the size of your board. So we'll do that right now. We'll go to design, we'll go to edit board shape, and this allows you to drag your board edge over to like a reasonable distance. So it doesn't need to be that much bigger than the actual components themselves. And we'll just zoom in on that using our scroll wheel and pan it over using the right click. And yeah, that's our board design view. 2 is our component design view. So this allows us to move our components around. We can see the different layers of the board very easily. So this red corresponds to the top copper layer of the board, which you can choose the thickness of that copper layer. You can choose the name of that copper layer. Then you've got the bottom layer, which is the bottom copper layer of the board, assuming a 2-layer board. And then you've got a mechanical layer. So if any of your packages have mechanical components, they'll show up here. Then you have your top overlay, which is all your silk screen. So all this yellow, all your writing on your board, your bottom overlay, and then your paste, your solder mask, and a few other things. So what's really important for our case is the top layer and the silk screen. So you can see that we have a little bit of metal here because this diode is a surface mount component, so it has metal pads. The rest of these are through-hole components. So they have holes in the board. There are vias here through which we place our component. And then the third way to look at your board is by pressing 3 on your keyboard. You can look at your 3D view. So this is kind of a visual representation of what your board will look like in real life, so to speak. So you can see that your gold is yellow as you expect, your copper is yellow as you expect, your silk screen is white as it usually is, and your board as a whole is green. And if you have any 3-dimensional parts, if you have a mechanical component, or for some surface mount components, we'll show you how far they protrude out of the board. And so this is a useful sort of 3-dimensional way to look at your board. So let's go back to our component design view by pressing 2, and this is where we can move our components around. So I'll move the battery to one side, I'll move the capacitor to kind of the middle, and the resistor to the other side, and the diode to here. And you can see these thin lines. These are these thin lines that connect some of your components together. And these lines actually are guidelines to help you understand how the board should be routed. They help you understand what ends of which components, what ports of which components are connected to other ports. So the software knows that, and it's giving you a hand here. So this is useful because this allows you to plan out your routing in advance a little bit. So let's turn some of these components around so that this through hole on your battery is connected to this through hole on your capacitor. So now it is, you can see. And we'll do the same for this guy. Well, that's already connected, that's good. And we'll flip the diode around so that the top of this diode, or this net, is connected to this through hole. So, like I mentioned, the diode is a surface mount component, and the capacitor and the resistor are through hole components. But I find it a lot easier to work with surface mount components as often as possible. So I'm actually going to change the capacitor and the resistor to surface mount components. In order to change that, I have to change their footprints, or how they appear on my PCB. To do that, I have to go back to my schematic document. Actually, let me save this first. Hit save there. I'll go back to my schematic document and go to my symbol for my capacitor and double click, and that opens my schematic component properties window. I'll go to models here, and you can see my footprint is a radial footprint that's through hole with 2 leads. So I want to change that. So I want to add a footprint, And this is a lot like choosing a component. You go to Browse, then your libraries come up, and your libraries have a bunch of footprints on them. So I'm going to pick a capacitor 1206 footprint. And pick that. Everything looks fine. Hit OK. And now you can see my footprints changed. Now, chosen C1206. So I hit OK. And my circuit hasn't changed at all. As you can see, the capacitor symbol is still the same, but the footprint has changed. And we'll do the same for the resistors. So I'm going to add footprint, browse, and I'll actually pick the same. Switch libraries. I'll pick the same footprint. 1206 is a pretty standard size for resistors and capacitors, so that should work. And then I hit save. Now I want to import those changes over to my PCB. So to do that, I go to Design, Import Changes again. Again, my change log comes up. Again, I deselect rooms, and you can see we've changed our footprint from a surface mount to a through. Changed our footprint from a through hole to a surface mount in both cases. So that looks great. We'll hit Validate. Everything looks like it's working. We'll hit Execute. And then we'll close it, and ta-da! We have surface mount devices. We'll move our labels a little bit so that they're a little bit closer to our devices, and that looks fine. So now it's time to route. Now it's time to actually draw traces from one side to another. So let's do that. So to draw our wires, we go to Route and then Interactive Routing. Now we have a cursor, and we select whatever pad that we want to connect to, whatever port we want to connect to. So when we've selected a port, when we've moused over the appropriate port, you'll see the cursor obtain a circular component. So that lets us know we've selected a port. Then we click, and now we move our mouse around, and our trace will come with us. Now you notice when you're doing interactive routing, all of the irrelevant ports are grayed out. So all the other pads over here that I can't connect to are grayed out. And so I'm like, my trace is dodging around them. So I want to just go here, and I know I'm connected to the pad because a little circle will appear, and I just click, and there you go. So now we'll do this one. Yep. Now one thing you notice about routing is that unlike schematic design, the traces don't form right angles. We actually want to avoid right angles. That's because when you're dealing with high frequency applications or particular types of signaling, you actually lose your signal integrity at corners. And if you have a right angle, you actually lose a lot of signal integrity. You'll get a lot of reflections at that corner and the like. And so it's very common when laying out PCBs to not do things at right angles. And so we're just following that convention. So that's connecting that. And then finally, we do our ground, which will go around here for ground. So this is our ground. Great. And then we'll hit escape to close out of our routing cursor. And we'll make that a little more aesthetic. And there you go. That's our circuit. So that's our, just move that a little bit to the center of the board. That's our circuit laid out. Now comes probably the most frustrating but very important part of using Altium. So save there, and that's design rules. If you want to get typically you'll fabricate PCBs through a third party, through some kind of foundry that'll make them for you for a low price. However, it's important that you follow the manufacturing specifications of whatever third party you choose. So the software Altium will actually keep track of those specifications. We call those manufacturing specifications design rules. So to set design rules, we go to Tools, or rather we go to Design and Rules. So we'll click Design Rules. These are our rules and constraints. So we have electrical rules, we have routing rules, we have mask rules, we have manufacturing rules. So there are, Altium has a sort of default rule set that it will just saddle you with once you've started working. But we're going to make some changes. The first change we're going to make is in the electrical tree. We're going to go to clearance. So this is the clearance between all of our electrical traces. and we're going to set this minimum clearance to 6 mils. And hit enter. So you can see in this matrix here, all of our minimum clearance values have been set to 6 mils. So between any two metal structures, the closest they can be is 6 mils from each other. We're also going to hit this checkbox that says ignore pad-to-pad clearances within a footprint, because that allows us to, when we're using imported footprints like we are now by default, we are basically saying that we're assuming that these footprints already adhere to the design rule specification, that it's not a big deal. This is a good assumption to make if you're dealing with really standardized footprints, which is what we're dealing with right now. So we'll hit apply. The second change we'll make is under routing width. So this changes your width of your traces that we just set, these red lines. So I'm going to set the minimum width to 6 mils. The preferred width I'll leave at 10 mils, and the maximum width I'll change to 40 mils. And these are just my personal preferences for dealing with trace width. Your mileage will vary depending on your use case. The next change I want to make is under manufacturing. It's actually the hole size. So whenever you drill a hole into your board, whether it's for a through-hole component or for a via for routing, it's going to be subject to these constraints. We're going to set our minimum hole size to 13 mils. That's the change I want to make there. Then I'm going to change the silk to silk clearance. So all these white lines, all these yellow lines on your PCB document, the minimum distance that they should be from each other, I'll set that to 6 mils as well. So we'll hit apply. And one more change, we'll change the minimum annular ring size. So currently there is no design rule set for the minimum annular ring size by default. So we'll add a new rule, and it's the minimum size. So we'll just double click our attributes and we'll change that to 7 mils and hit apply. Alright, so those are all design rules set. So hopefully we've met all of those design rules, but we want the software to tell us if we have. So now comes what I think is one of the most important parts of Altium, the design rule check. So let's hit save. The design rule check is basically checking all of your rules, making sure that they're all being followed. So we open up our design rule checker, which is under tools, and click run design rule check. And we can close out our messages table and look at, we have 0 warnings and 0 rule violations. So that's fantastic. That tells us that we're done. We've designed our circuit. We can go to our 3D view. You can see our surface mount components sticking up off of the plane of the board. And we can see our traces drawn on them. And that's it. So the last thing I want to show you before signing off is what happens when you fail a design rule check. So let's start by adding a wire where there isn't supposed to be one. We'll go to interactive routing and we'll just draw a wire out to here. Great. So that's bad. Design rule check will complain about it. We go to design rule check, we run it, and yep, see, rule violation. One rule violation, we go down to here. It's a net antenna, so we've just got a wire sticking out in the middle of nowhere. And when we click on the error in the design rule verification report, it'll take us right to a zoomed in view of, nice and zoomed in of what the problem is. So we can just get rid of that segment, hit save, and run a check again just to confirm that we're back to 0. 0, 0. Fantastic. So that's all. We'll hit save. That's our circuit. That's our PCB. And so I hope you learned how to use Altium to design a pretty simple circuit. And good luck, and take care.